Hello, ladies and gentlemen. I hope that your quiz went well today. We are going to move on to some different types of equations. In that quiz that you just took, we were solving single step, we were solving multi-step, we had variables on both sides. Now we're going to move into something called proportions. And in order to solve proportions, you have to know what a ratio is. Okay? A ratio is a comparison of two numbers by division. And this is basically a fancy way of saying a fraction. Okay, because you all know that a fraction has a numerator and a denominator, so that would be your two numbers. And you also know that the fraction bar means to divide. A proportion, then, is stating that two ratios, okay, two fractions, are equivalent. Okay, so if we talk about what a ratio basically is a fancy way of saying a fraction. So something like that. That is a ratio. Okay, let's make that be a little bit better. If we go ahead and make a proportion, then I need two ratios that are going to be equal to each other. Okay, so there's kind of the difference, a ratio and a proportion. Now, so the first thing I'm going to ask you is, can you tell me if 7/8 and 49/56 are equivalent ratios? So if they are equivalent, that means they have to be equal to each other. Well, we just mentioned that the fraction bar means to divide. So if you go ahead and divide, hold on one second here, folks. All right, sorry about that, ladies and gentlemen. So if I want to know if these are equivalent, I need to go ahead and see if they represent the same decimal. So 7/8 is 0.875 and 49/56 is 0.875. So are these equivalent ratios? The answer is yes. When you divide them, you get the same decimal representation. So let's do the same with my other ratios down here. I have 2.8 over 4.4. That looks like 0.63 repeating. And I have 1.4 and 2.1. And that gives me 0.6 repeating. So are these things equivalent? The answer here would be no. Okay, well, if I'm asking if they're equivalent, basically I'm asking if they're equal. Well, we just recall from those definitions I gave you that when they're a proportion, that means that they're equal. So if I am looking at this next set of problems where it says 2 over 2.5 and 16 over 20 form a proportion, well, if they form a proportion, that means that they have to be equal to each other. Okay. And again, you can do this the same way. You can take 2 divided by 2.5, and this gives me 0.8. You take 16 over 20, this gives me 0.8. So you would say yes, these two things are equivalent. They form a proportion. Or if I go ahead and do it as a proportion, 2 over 2.5 is equal to 16 over 20. When we have proportions, we can cross multiply to see if they are equivalent as well. So 2.5 times 16, that gives me 40. And I have 2 times 20, which also gives me 40. They are equal, so that's another way that you can check to see if they form a proportion. You can set them equal to each other and cross multiply. Either way you slice it, whether you find the decimal representations or you cross multiply, you still see that they are equivalent. Okay, so if we do the same thing with 0.25 and 0.6, we'll do them both ways again. If I do my decimal representation, I get 0.416, and the 6 is repeating. If I do my decimal representation here, I get this. So you would say, no, this does not form a proportion. Or I could go ahead and make that proportion and I could cross multiply. So 0.6 times 1.25 gives me 0.75. So there I just multiplied those two together. Now I'll do these two and I get 0.5. So no matter how you slice it, those are not forming a proportion. Okay, so now let's go ahead and solve some of these proportions. Now remember, I've got a fraction equal to a fraction, and like I just briefly introduced to you, we can cross multiply here if we have two fractions that are equal. So if I multiply this times this, that gives me 8n. If I multiply that times that, it gives me 36. Now in order to solve for n, I will isolate it. Looks something like that, and you will get 4.5. So 4.5 is what n would have to be for those two fractions to be equivalent. Let's do the same thing over here. And we'll cross multiply. It doesn't matter which way you cross multiply first. Then we will solve. So I get w equals, and that should be 7. Okay, moving on down here. Let's go ahead and cross multiply again. Let's go this way. 51 equals 51x. If we go ahead and solve for that x, we will isolate it. I get x is 1. Okay, so looking at number 4 here, same idea. Okay, I need to take this times this. Well, when we do that, that 4 in the denominator needs multiplied by this entire side of the fraction. So I'm going to put that out front and I'm going to put it in parentheses. And then we have a 36 on the other side. So we'll need to go ahead and distribute this and then solve like usual. Okay, now we'll isolate that x. And you get that x is 5. Okay. Let's try another one like that. We need to go this times this, so we're going to distribute that 10 to the x minus 5. 15 times 4 is 60. And we're just solving these like usual. Remember to stop and pause this video as you need in order to keep up and solve these proportions. We're going to cross multiply. Means I'm going to need to distribute that 3 to the 9b minus 3. Looks like that. Distribute. Looks like that. Now I'm going to get my b's together. Okay, remember I've typically told you to move the smaller b over. And now we'll move that 45 over to get the b by itself. Gives me negative 54 equals 18b. Divide by that 18, and you will get b is negative 3. Okay, distribute. Get your v's together. And divide by that 50. This will not be a whole number. I get v equals, I would leave it as 4/5. You could also have the decimal, which would be 0.8. All right, let's do one more here before we move on to your handout. Move that 27 over by subtracting it. Then we will divide by the -9, and let's see what we get here. That gives me 2.5 repeating, or you could have your fraction, which would be 2 5/9. You also could do the improper fraction, which is 23/9. Any three of those representations would be acceptable. Okay, let's go ahead and move to that handout. Let's do some word problems with these proportions. When we are doing word problems, basically we are comparing two things. And if you look at number 1 here, I have a dripping faucet. So I am comparing the cups of water that it wastes to the amount of time that it takes for that. So that's where I'm going to do my proportion. When you're doing your proportion, you need to make sure that your ratios, your fractions, go in the same order. So here I have cups and I have time. So I need to make sure that I set up my ratios that way. Okay, so I have 3 cups for every 24 hours. And then I don't know how much water for a week. Now, my time here is in hours. So I need to turn a week into hours. So there are 24 hours in a day times 7 days in a week. That makes 168 hours. And now you're ready to cross multiply to solve this thing. So that'll give me 24x is equal to 504. When you solve that, you should get x is 21 cups. Okay. All right, moving on to number 2. If you'll take a look at that one, you will see that we are comparing the packs of toothpicks. I'm sorry. We are comparing, I'm looking at the wrong one. I'm looking at number 3. We are comparing the gallons of gas, and it looks like the cost. So that's how I'm going to set up all of my proportion here, both of my ratios. I have 5 gallons for $14.46. And then I need 16 gallons, but I don't know how much that is going to cost me. So if we cross multiply in our proportion here, we get 5x equals 231.36. And then if we solve that by dividing by the 5, we get 46.272. Now we're talking about money here, so we need to round appropriately. We only want 2 decimal places, so that would be 46.27. All right, number 3. Now we're talking about packs of toothpicks. And we are also talking about the cost. So 3 packs cost me 87 cents, and I have 10 packs, and I don't know how much is that going to cost me. So we are going to go ahead and cross multiply. Gives me 3x equals 8.7. Divide by that 3, and I get $2.90. Okay, moving on, go ahead and read here about the Willis Tower in Chicago and the John Hancock Center in Chicago. If you do ever get a chance to visit Chicago, these are some really awesome buildings, and they do have some observing decks. You can take an elevator all the way up to the top and check out how high you are. All right, so it looks like we're talking about the height, the actual height of each building, and we're talking about the replica height. Now, a replica is just like a small version of that. So for the Willis Tower, I have 1450 for the actual height. And it also tells me that the replica is 3 meters. So now for the Hancock Center, it is 1127 actual, but we don't know how tall that replica will be. So we're going to cross multiply. Gives me 1450x equals 3381. Then we're going to divide to isolate there, and you're going to get approximately, let's go to the nearest hundredth. So the hundredth is 2 decimal places. So that gives me 2.33, because after that second 3 is a 1, so it's going to stay at 3 there, and those are meters. All right, why don't you go ahead and try this one on your own? Okay, go ahead and read it. See if you can set up your proportion. Go ahead and pause it right now and see how you do. And then unpause it, and I'll show you the solution. Okay, so you should get 4.5 hours, 4.5 hours to paint that room. All right, let's do the same thing. You go ahead and pause this video, see if you can work out this problem. Then when you're finished, unpause it, and we'll go from there. Be careful here. There's some numbers in here that you don't really need. So you should get 56.25 miles. All right, folks, go ahead and complete your notes check for today, and I will see you tomorrow with any questions.